trying to figure out what part of what you need to be able to figure out is the difference between when to calculate local versus absolute extrema. Okay, so here's the biggest indicator. A local extrema, min-max, okay, there will be a function without an interval. Okay, so it'd be like f of x equals x squared. Okay, we just give you a function. What are the extrema of that function? So if you look at the graph of this, right? Is there an absolute max? No, there's not. Okay, absolute. Okay, there's an interval. Or they will say calculate the absolute extrema, okay? This is a subtle difference. So we would say something like that. Okay, see how we've restricted the domain? Do I have an absolute min and max now?
Yeah.
Yeah, I do, because I've restricted where that is actually valid. Okay. There are a dozen ways to ask these questions. Okay. The hardest ones to flesh out, we'll look at some tomorrow, will be like grass clippings are decomposing at this rate. When is the fastest they're decomposing? Is that an absolute or a local?
Absolute.
Yeah, that's an absolute question. Because they're asking when is it the fastest done. Okay. And they'll give you a time interval there, like 0 to 8, to work with. Okay, so we have to be very wise about analyzing which of those to use sometimes. Sometimes it's very obvious. We use a similar process for absolute extrema and local extrema. Okay. The analysis, so the work, so the calculus and the algebra for both of these is the same. We'll still calculate a derivative, we'll still set it equal to 0, we'll still get the x values. Okay.
Orlando Johnson, Kenneth Kirsten, Landon Lewis, David Lobo, Jebediah Lopez, Dyra Loya, Eric Martinez, Wyatt McAnally, Clayton McKeon, and Derek Medina to the office.
There's a good E for you. So, okay, so the algebra and the calculus are still the same. You just use a different test. Okay. For local extrema, we use the first derivative test, the sign analysis, right? Okay. With absolutes, we're going to do what's called the candidates test. Candidates, yeah, like election candidates.
What was the one we did?
Yesterday, first derivative test, sign analysis. People use those phrases interchangeably. So, find the candidates with your calculus and algebra, and then use the candidates test for it. All right. So, let's just start with a polynomial. Sure. All right. So. Okay, absolute or local?
Absolutely.
Yeah, why?
Single.
You have an interval. Okay, so we will use the candidates test. This is like nebulous big idea right now. I'm going to show it to you. So same calculus. What's our first step? Okay. Luis, what's the derivative?
6x squared minus 30x plus 24.
Okay. Ooh, I see something to do. Factor out.
6.
Yeah, get rid of that 6, because it's in every one of them. And that's such an easy factor. So what are the factors? Am I going too fast? Let's slow down.
Negative.
X minus.
Oh, yeah.
So the zeros are 2 and 3. Okay. We did that yesterday, right? We've done that 100 times already this year. But for local extrema, we would now do a sign analysis, right?
With the chart.
But for absolute extreme, you have to use the candidates test. So, we're going to test the critical points and endpoints in the original function. What?
When you factor out 4 plus 6 is 4 plus 4. Did you factor out 6?
Yeah, because 24 times 6 is...
I'm just testing.
Oh.
Yeah, but I'm like deaf. Don't you know? Yeah, I know. That even validates my statement more. Okay, so we have these two.
Yeah.
And that changes things. Quiet. Is that better? Okay. Now you got me sweating bullets. So this is the best way I found to do this is with a table.
Why is that feeling?
Okay, the endpoints are 0, 6, right? They're the endpoints, 0 and 6. And the critical points, 1 and 4. So 0, 1, 4, and 6.
So you do your 2 endpoints with the...
Yes, the endpoints can be your high and low,
And then you do
right?
2
Or the critical values can be your high and low. So we gotta test them all.
Justin Miller, Peyton
Test them in
Nye,
alphabets.
Jackson Olinger, Connor Ostemiller, James Owens, Logan Paskett, Rhiannon Patton, Matthew Pettit, Carolyn Quintanilla, and Katie Ray to the office.
Why do we test them in F? Anybody have an idea? Yeah, it's just this is the Y values, right? It gives us the high and the low spots. Tells us, it just gives us a direct comparison. So what is F at 0? And then F at 1? 2 minus 15, negative 13, plus 24. 11 plus 7, 18. Am I right? You already busted me once on my factoring skills.
Well, division.
Okay, put 4 in.
Is that the derivative or the?
No, we're working with f of x. That's
16 times 4 is 64. 128.
yeah, 128.
Minus 15 from 16.
$181. Is it? I don't know if that's right. You check it. It's not. It's 241.
It's 240.
Okay. What do you get?
96 plus. So what is that? What do we say what the 2 extra bit was?
128.
128 minus 240. Plus 96. Plus 8. It's negative 9.
Okay. Can I do 6 as well? It's 43.
How do you do that? You wait till the book?
What? Yeah, smart.
Okay,
I can't factor, but I can add the exponent. I can add now. What's the maximum?
4. It's 9.
Would you like to revise your
I would
statement?
like to.
Max here?
Yeah. I was looking at sign something.
And min, right? There you go.
That's way easier.
No,
Oh,
it's the same amount of work, really.
Nothing's wrong with it.
Okay, so that's kind of what your graph looks like, right? On the interval. So you got your minimum here, your maximum there. Questions? We're gonna work on this a little more tomorrow. So,
All this is, she's like, I don't want to do this.
because I did want to show you a few more examples, but we're out of time. Nope, doing 3.
oh, cool.
Keep talking, I'll just keep going.
Who's that first one say? Oh, yeah.
Okay. I'm giving you 2 days to do this, so quit your sniffling.
Oh, okay.
So tomorrow we'll take a look at 4.2a again. Do your min-max first derivative test. I would suggest starting this, at least do a couple. And then we will check this Friday. Tomorrow I'll show you a couple more basics, but I want to jump into some AP problems as well. That's all for now, folks.
That's mine.